Hello and welcome to another of my Core 2 revision videos. Today we're going to be talking about logs. Now first of all I'm going to go through the rules of logs. These are things that you just have to remember. There's no easy way to do it. You just have to sit and memorize them because you will need them. They will definitely come up on the exam. So the first one is kind of the definition of what a log is. That is, if you have a number to the power of another number is equal to something, that can be expressed as log to the base x of a is equal to b. And that's kind of saying what a log actually is. A log is saying what power do I have to raise my base to get my answer, and that's how it transforms. So it's sort of x to the power of b, if you move this in, is equal to a, and that's what we started with. So that's the first, what a log actually is. Now the rules of logs, I'll do those in a different colour. Let's get blue out. The first one is, if you have log, we'll just put it to the base x of a, plus log to the base x of b, you can write that as log to the base x of a times b. So that means if you've got two logs added together, you can combine them. And also, if you have a log of a number that can be split into two factors, you can separate it. So that's the two uses of this rule. Next one, very similar. If you have log x to the base log to the base x of a, you take away log to the base x of b, this one will get you log to the base x of a over b. So again, that means if you're taking away two logs, you can put them into one log with a divide, and if you have a log of a fraction, you can split it up. So again, it's combining and splitting these logs. The third rule is if you have log of a number to a power, that can be wrote as the power times by the log of that number. This is a very handy one, but you have to note that if you had something like, let's say, log x of 2 times 3 to the 4, you could not use the trick here because the whole thing isn't to the power 4. If you had brackets around this, you could, but if you didn't, you would first have to use our first rule to split it up, then you could bring the 4 forward. So it's important to note the power has to be of everything that's inside that log. And the final rule I'm going to make is if you have log to a base of the same number as the base, that is equal to 1. Now, you will need to know these rules because if it gives you a log question that says, like, show this equals this, or if we're lucky and we get a question that's in the first half of the paper and it's just combine these logs, that would be a very nice question. But either way, you're going to need to know how to use these rules and be confident in them. So I'm sure you can find some questions if you need to practice them. And really, it's just remembering these 4 rules. If you're adding them, they become times. If you're subtracting them, they become divide. If you've got a power, you can bring it to the front if the power's to everything. And if the base and the log bit are the same, it equals 1. So those are the 4 rules. You just need to sit and remember them, really. Now, possible questions. Let's go back to red. Now, as I was just saying before, the best question we can hope for on logs is one that will be in the first half of the exam, and it will literally say, express log to the base 2 of 4 plus log to the base 2 of 8 as a single log. It will probably have, say, part A, B, and C, and they'll get progressively harder, and it'll just be testing that you've remembered your log rules. There'll be, if you remember them, if you take the time to sit down and just memorize them, it will be easy marks, so it's something we can really hope for. So this is not one you really have to worry about, so I'm not going to talk about that for much. Another way they could bring logs into the exam is through a AP and GP question. So one of the formulas for geometric progressions is the nth term is equal to the first term times the common ratio to the power of n minus 1. So you might get a question that tells you about a GP and it ends up with A equals, let's say, 8 and R equals 2. Why not? And it says, what is the first term that is greater than, let's say, 100. So we'll have an inequality here of 8 times 2 to the n minus 1. Now here, you're going to have to use logs because you want to get n equals something. But of course, you can't bring them forward if there's an 8-bit here. So the first thing I would do in this example is I would divide by the 8. So I'd get 100 over 8 to 2n minus 1. Then you could take logs of them both. So you'd get the log of 100 over 8 to the log of 2 to the n minus 1. Now, of course, we can bring this forward. So we would get n to the minus 1 of log 2, which will expand to n log 2 minus log 2. So we would add log 2 to both sides. We would get log of 100 over 8 plus log 2 is less than n log 2. Would then divide by the log 2. So we'd bring the log 2 under here. And we would get a value for n, so you type this into your calculator. And also a trick with inequalities, there's a rule sometimes you've got to flip them. I never remember it, to be honest. So what I always do, once I get down to my number, this is likely to be a decimal, I haven't put it into a calculator, so let's just say that the decimal was 17.34. Obviously, it has to be a whole number for an AP or a GP. So I would try 17 and 18, see which one is actually the one that works in our original inequality, and through that get the right answer. But really it's just remembering your log rules and using them in a bit more of a creative way because it's in the context of an AP and a GP. And again, if you remember those rules, you should have no problem. Now, the really horrible question that they could ask you on logs is to show that something is equal to something else. This is more likely to come up in the later half of a paper. I've seen it as the last question on a paper before. And it is quite horrible because it is just trying to work out how to get from one to another. The trick that I always do is I look at what we're trying to get to and what base they have used. In this question, it's a 3. Now, I will always use that base while I'm doing this question because I'm going to have to get it to that base by the end, so why not just do it straight away? So in the example of this, I would first off, I've noticed that it's to the base 3, so I would do log to the base 3 of both sides. So I'm going to have to do it at some point. So I would have log to the base 3 of 6 times 5 to the x is equal to log to the base 3 of 9x. Now, same thing here. It's got a power, but I can't run it forward until I've split it up. So I would split it up. I would get log to the 3 of 6 plus, and then I could bring the x forward to get x lots of log to the base 3 of 5. And that would equal, I can bring this x forward, x lots of log to the base 3 of 9. Now, the second thing I would notice is it wants it equal to x. So I would try to get all of the x terms on the same side. So I would subtract x log 3 to the 5 from both sides. So I get log 3 to the 6 is equal to x log 3 to the 9 minus x log 3 to the 5. So now I've got all the x's on one side and all the things that don't have an x in them on the other. I can factorise this and get my x on its own, which is getting me a lot closer to getting the right answer. So that would get me x lots of log 3 to the 9 minus log 3 to the 5, which of course Of course, I would then divide through by to get x on its own. So I would then have log 3 to the 6 over log 3 to the 9 minus log 3 to the 5. So let's write that up here. Log 3 to the 6 over log 3 to the 9 minus log 3 to the 5 equals x. So now I've got what x equals to. I know I'm in the right base because I checked that straight away. So now I would look over to what I have that's here and what I need that's here. Or negative log 3 to the 5 on the bottom. We've got that, don't we? That's just here. So I don't want to do anything to that. It's these two that I need to change. Well, this has got 2 here. And if we look, we can remember one of our laws was that anything to the base of itself is equal to 1. And also, if we have something we can split into factors, we can make it log of the factor plus log of another. Well, 3 times 3 is 9, so we could have log 3 to the 3 plus log 3 to the 3. Since they're both 3's, they become 1. 1 plus 1 is 2. That's where the 2 comes from. So we get log 3 of 6 over 2 minus log to the 3 of 5. So now we've got all this right, it's just this top bit that's wrong. So let's look at what we have here. 1, well, we know the only way to get a 1 is when you've got the base the same as the other bit. So what factors can we split this into? We need one of them to be 3, the other one has to be 2. So that would get us log 3 of 2 plus log 3 of 3, which is 1, over 2 minus log 3 to the 5. So now we know that this bit's right and this bit's right. And actually, we've got this end bit as well, just by the process of going through. So this is a really horrible question, but the tricks are to notice straight away what base it wants it in at the end, and to take the log to that base as your first step. Then you need to use your rules to get your x at the front of your logs. Then get all the x's on one side and factorize so it's x equals something. And then compare it with what you're trying to get to and use your rules to change it slightly, compare again. And it's really just going through and checking. It's a horrible question and it will be a hard one if it does come up. But even if you don't get all the way through, probably 1 mark would be for using the same base. You probably get another 1 or 2 for getting it to be x equals. So it's good to remember those little tricks just to pick up some extra marks. But really, as far as revision goes, practicing the harder questions are good. But really, you just want to remember these rules. If you're adding them, it becomes times. Subtracting is a fraction. To the power, you can bring to the front if the power's to everything. And if it's the same base as it is the number, it equals 1. You literally just have to sit down and memorize those, and you should be able to at least pick up quite a few marks on these log questions. So, thank you for listening. I'll try and answer any questions if you leave them as a comment, and let me know if there's anything else you want to know about. See you later, guys.